Okay, good afternoon, ladies and gentlemen. So, our objective for today is the same one that we've been doing for the past couple of days. We're learning how to apply and understand the rules of exponents. All right. So, today's lesson is going to look slightly different than the last two because the main thing that we're trying to focus on today is some rules that has to do with negative exponents. So, to try to figure out what it means to have a negative exponent, we're first going to look at an example with some positive exponents. All right. So just a really quick review, stuff we've been going over the past couple of days. When you have a number like this, we usually refer to it as a power. The small number on the bottom left, we call it the base. And the number on the top right, that's a little bit smaller, we call the exponent, right? So we just want to try to make sure that we're using the proper terminology when we're talking about these things. So very first thing that we're going to do is simple. We're going to try to fill in the table below. So let me just explain what you're looking at and show you the first couple of numbers. So over here, these are the values of x. So I'm looking at numbers between 1 and 6. And each of these columns represents an exponential power. So this is 1 to the x power, 2 to the x, 3 to the x, 4 to the x, 5 to the x, 6 to the x, and so on, right? So the idea here is this is 1 to the x comes from here. So what I'm going to put in this value is 1 to the first power, which is just 1 times 1, that's 1. Same thing for this one here. This is 1 to the second power. So to figure out the power, I'm going to look at the left-hand side. So 1 squared I know is also 1. I actually know these are all 1, so I'm just going to fill those in. Right? Doesn't matter what power I raise 1 to, 1 times anything is always just going to stay 1. Now, similarly over here, I have 2 raised to a power. So let me just write it out so that we're clear. This is 2 to the first power. I know 2 to the first power is just equal to 2. The next one, 2 to the second power. So that's going to end up being 2 raised to the second power. I know that's equal to 4, right? Next one again, 2 to the third power. I'm just going to skip writing it out. I know that's equal to 8. 2 to the fourth power. I know that's equal to 16, right? I go over to the 3 side. 3 to the first power is equal to 3. 3 to the second power is equal to 9. Remember, that's 3 times 3, not 3 times 2. Then similarly, 3 to the third power, this one is going to be equal to 27, right? So remember, what am I doing going down here? I just need to multiply by 3. So this is going to be 27 times 3. Similarly, I do the same thing for 4. So 4 to the first power, we know is just equal to 4. Go on to 4 to the second power, multiply by 4, multiply by 4. So just like we've done in the past with dealing with those exponential tables, you're going to go ahead and fill in the rest of this table here, and then we're going to look for a pattern. Okay, so pause the video, work on this section here. And once you're done with that section, you're going to look at the questions on the next 2 pages. So it says, look at the top of the 4 to the x column. So looking back at this table here, the 4 to the x column would be this column here, right? So looking at that column, it says, what did you do to move down the column? All right, so for example, did you add 3 each time? Or did you subtract 7 each time? What am I doing to move down the column? So to move from this number here to this number, and then to move from this number to this number, what operation are you doing, right? Are you adding something? Are you subtracting something? But specifically, I want you to write out what exactly did you do, right? If you said you multiply by something, what did you multiply by? There's a reason why we're doing this. Then next thing, it says starting from the bottom of the 4 to the x column, what do you do to move up the column? So if I'm thinking about starting at the bottom of this column, down at the bottom, how would I go from this number here and get to this number? What operation do you have to do? Similarly, to go from this number to get to the number above it, what do you have to do to get to that number? And I gave you a hint. What you have to do is going to be the opposite of whatever you said that you did in number 1 to move down the column, right? Once you have those 2 answered, what we're going to try to do is use those observations to work backwards, filling out the table, right? So what you see right here, that's actually just taken from the table that we had above, right? That's like me just taking the first 3 rows of this table and putting it down here. But what I did then is I'm extending the table upwards. So if I want to extend the table upwards, what am I going to end up having to do here, right? And the idea is, you already know how to do that. That's going to be your answer to question number 2, right? What you should have observed in question number 2 is that if I want to move up the table, I'm actually dividing instead of multiplying. So, for example, right here, to go from 2 to 4, we multiply by 2. But if I want to go in the opposite direction, I need to divide by 2. So 4 divided by 2 gets me to 2. And then if I want to again go up one more time from 2 to the next column in my table, I'm going to have to divide by 2. So I'm starting with 2 divided by 2. That's going to give me 1. And then again, to go from here upwards once more, I'm going to have to divide by 2 again. So 1 divided by 2 gets me 1/2. And then going up one more time, I have 1/2. I need to divide by 2 to move up my table. So 1/2 divided by 2 is going to give me 1/4, right? And then again, I would go up one more time, dividing by 2 if I wanted to. Over here is a little bit simpler. I started with 1, I'm dividing by the base, which is 1. 1 divided by 1 is just 1, right? And again, I'm moving up the table here. Let's just show you what I did. So again, it's going to be 1 divided by 1. That's just equal to 1. And then again, to go from here upwards, I need to divide by 1 again, so that's also going to be 1. So the idea is when you're moving up the table, you're dividing, right? So what I want you to try to do yourself is to finish the rest of this out. So what are these numbers going to be over here as we continue moving up the table, dividing by the base, right? So I want you to work on that part there. Pause the video so you have some time to work on it. And then what we're going to do next is try to make some observations. So it says, examine the table that we created in part 2. What happens when the exponent is 0? So that means you're looking at this row here, this middle row, when the exponent is 0. What do you notice about all of these numbers? Write that out in words. Then, using what you noticed, I want you to fill out this table here, right? It should be very easy. If you're stuck, please make sure you come to the Zoom session so I can explain that. Now, it says examine the table that you made in part 2. What happens when the exponent is -1? So looking at this row here, what do you notice happens with all of these numbers? Can you explain in words what's going on with these values here, right? Write that out in words, then use your result to answer these here. Again, if you understand the rule, these should be pretty simple. Okay. Now, last thing says that you can kind of generalize the results of having a negative exponent to say that something like a base raised to a negative exponent is just equal to 1 divided by your base raised to the exponent, right? So it's a little bit confusing, but once you understand those first parts, this should make a little bit more sense, and I can help you with this section in the Zoom session, right? That's it for today. Please make sure you're in the Zoom session so I can help you out with this stuff, all right?